Physics video number 11. Yep, electricity. Electrons on the move, baby, in motion. Static electricity, remember they were just ready to move. But now electrons, they actually move in electricity. So if you look on your sheet number 55, how does resistor length, temperature, and area affect resistance? Remember we did the then we got closer, cross-sectional area got smaller, farther apart it's bigger. If we did cold, hot, we made it longer, that all affected it. So the equation for this is like that. So for instance, if I have that little conductor and then I have one twice the cross-sectional area, let's say, but the same length, which one's easier for you to go through? If you're an electron or if you're a little kid, you know? So if you're a little kid at McDonald's, and one person told me there's no little kids at McDonald's. Haha. But anyway, if you're an electron and you're trying to get through here, isn't this one easier to go through? So if this one's 10 ohms, that's a bad ohm. If this is 10 ohms, then this one might be 20 ohms. Okay? And remember we got volts, ohms, and amps. You must be careful with volts, ohms, and amps. With the voltage to jolt, the resistance to gulp, and the current begins to flow. Remember that little song. So what we have here is your resistance versus your length. It's going to be directly related. And by the way, the resistivity, this is resistivity. Ohms times meters, depends on the metal. Aluminum, nichrome, tungsten, whatever it is. This is resistance, which is ohms, which is depends on the type of metal, the length, and the cross-sectional area. So if we're looking back here, this is going to be like that, right? And then resistivity, you probably wouldn't have that because, you know, that really wouldn't be graphed. But if you did do it, I'll just put it up here. Resistance versus resistivity is like that. Okay, there are 3 different types of circuits. Just joking. 2. Series and parallel circuits. Series circuits have one path, right? And parallel circuits have more than one path. So, one thing that applies to all of them is our old buddy Ohm's law, which we normally wrote like this. On your reference tables you see it like this. Okay? R equals V divided by I. But if you look, you can use this. Remember, we use this for all the different ones. R equals V over I, V equals I times R, and I equals V divided by R. Do you remember what each of these is measured in? Resistance is in ohms. Potential difference is in volts. And this current in amps, CIA, current in amps, that's going to be your current measurement is in amps, coulombs per second. So this is your Ohm's law circle, and I will talk about next about series and parallel circuits.